Assalamualaikum student. Today I will lecture on the bearing capacity in shallow foundation. Okay, so uh, first and foremost you have to understand what is shallow foundation, what's the difference between shallow foundation and a deep foundation. Okay, for the shallow foundation, meaning that the foundation without a part. Okay, so we call it shallow foundation lah. Okay, one more thing, the ratio, okay, the D over B usually is less than 5. Okay, so the depth of the foundation usually is less than 3. Okay, so we go to the slide presentation. Okay, our slide. Okay, so our first slide, bearing capacity and shallow foundation. Okay, so for the introduction. Okay, so foundation is the lowest part of the structure. Okay, and the shallow foundation is the structure member to transfer the loads from the superstructure to the soil. Okay, which supported the structure lah. Okay, so what is superstructure? Superstructure is refer to the structure above the ground or above the foundation. Okay, so the purpose of the shallow foundation is to convert the loads from the superstructure, okay, into pressure and apply to the supporting soil, meaning that the soil supporting the loads lah. Okay, so it's should transfer the loads without overstressing the soil. Okay, if you overstressing the soil, then excessive settlement, okay, or the shear failure will occur lah. Okay, what is such excessive settlement? Excessive settlement meaning that the settlement occurred because of the overloading. Okay, and if the we are overstressing the soil, okay, excessive settlement or the shear failure will occur, and then it will damage our structure lah. Okay, so you have to evaluate again the bearing capacity of the soil. Okay, okay, so when you design for your foundation, okay, so you have to check the stability condition. Okay, so you have to check the ultimate limit state and the serviceability limit state. So what is the difference between these two? Okay, so the serviceability limit state, SLS, is referred to the load, unaffected load. Okay, ULS, ultimate limit state, is referred to the loading, refer to the affected loading, meaning that you put F4S into the loading. Okay, so if the foundation, okay, if the foundation, okay, achieve the ULS, usually is this the shear failure or the settlement not necessarily occurred lah. Okay, so because you put factor of safety in the loading when you design. Okay, so what you have you have to check for the bearing capacity of the soil lah. Okay, and then if the SLS achieve, okay, definitely it will be settlement. Okay, so ULS is defined a limitation, yeah, for the deformation of the settlement. Okay, if it exceed SLS, okay, maybe the structure is not impair the function already, meaning that you cannot use the structure because of the settlement is already occurred. Okay, so that is the difference between the two lah, ULS and SLS. So you have to consider these two condition in your design. Okay, the Terzaghi, okay, propose that if the DF is less or equal to B, so it considered as a shallow foundation. Okay, so what is DF? DF is the depth of the foundation, meaning that the depth from the surface of the soil to the bottom of the foundation. So that is DF. Yeah, I will show you photo after that. And the B is the width of the foundation. So if you want to design for the shallow foundation, so you have to make sure the proportion and the size of the depth of the foundation should less than the width of the foundation. Okay, and other researcher propose, okay, is consider if the foundation the maximum depth of the foundation should less than 4B lah here, maximum 4B only. Okay, so it will consider a shallow foundation. If more than that, okay, if the depth more than 4B, then you cannot consider the foundation as a shallow foundation lah. Okay. Okay, so this is the explanation on the DF. So DF meaning that from the top, okay, from the surface of the foundation to the depth of the or to the bottom, bottom of the foundation. Okay, so that is DF. Okay, and then the B is the width of the foundation. Okay, so you have to know the variable. Okay, because in the examination, the variable, okay, is not explained. So you have to know. Okay, you have to understand what is DF, what is B. Okay. Okay. So this is the various type of foundation. Okay. So we have spread footing here. Okay. And then we have mat foundation. Okay, B is mat foundation, and we have pile foundation, meaning that we have pile here. Okay, here is pile, and then we have slab. Okay, on top of it. Usually we call it pile cap lah. Okay, and then we have drill shaft foundation lah. Okay. So shallow foundation versus deep foundation. Okay, so this is the different lah. how we indicate the foundation, whether it's shallow foundation or the deep foundation. Okay, so the shallow foundation is df over b is less than 4. Okay, so the example of shallow foundation is the spread footing lah, or pad footing, spread footing. Okay, mat foundation is a shallow foundation. Okay, deep foundation where the df over b is more than 4. Okay, the example of deep foundation is the pile foundation or the shaft foundation. Okay, the photo here, you can refer here. Okay, the previous slide. Okay. Okay, so this is the explanation on the footing itself. Okay, so individual footing, this one we call it pad footing lah. Okay, we have individual footing. Okay, with a column. Okay, so one column. We have footing supporting one column lah, so we call it pad footing. Okay, and then we have combined footing where when we have the column close to each other. Okay, so we can combine the foundation. Okay, or you have space constraint here, meaning that if you have structure or you have space constraint here. Okay, here. Okay, if you can also reduce the size with combining the foundation. Okay, so this area will help to hold this area. Okay, to support this area, so you can do the combined footing. Okay, so and then we have straight footing. Okay, when you have a load bearing wall, meaning that a wall, okay, without a column, that's a load bearing wall. Okay, so you need to have a straight footing lah, so we call it straight footing. Okay, and then mat foundation, when you have if your soil is very weak soil, okay, we don't want to have a differential settlement, then you can design for mat or rough foundation lah, to meaning that if you have a structure, so you have one large big foundation for that building. Yeah, so we call it as a mat foundation. Okay, and then you have straight foundation here. When you have wall, okay, you have small slab here, so we call it straight a straight foundation. Okay. Okay, so this is the photo of the shallow foundation. Okay, so first photo is slab on the grade foundation. Okay, and then we have rough slab house foundation. So this is the foundation for the house. Yeah. Okay, if you don't want to have a differential settlement, okay, when you have a very weak soil, okay, so you can you want to reduce, or you don't want to have the differential settlement, then you can have a very big foundation, okay, as a mat foundation or rough foundation, so that when if the structure settle, then it will settle together, so you won't see differential settlement. Okay, so and then you will have to support each other. Okay, so that is the purpose where we have rough or mat foundation. Okay, and then the last photo is the construction of shallow foundation. Okay, so how you construct a shallow foundation? Okay, so later on you will become the engineer, because then maybe you have to supervise a project. Okay, so how you install, how you construct the shallow foundation? Okay, first First you have to dig lah, okay, to get a hole, follow the shape of the foundation lah. So whatever shape of your foundation, okay, so we have a hole, okay, as in the photo, okay, and then you put first you have to put as spacer lah, the small ni, the small one, the small concrete here, okay, here, okay, so that is the spacer, we call spacer. Okay, so what is the purpose we put spacer? Okay, so we when you design for the structure, so you need to have a cover, right? So spacer is to allow the structure to have a cover lah. Okay, okay, and then after you put all the spacer, and then you put the reinforcement. Okay, by example here is the BRC lah, not reinforcement bar. Okay, so they put BRC, I think it's the BRC here, or they arrange the reinforcement. Okay, so whatever type of reinforcement that you use, okay. Okay, this one I think is the reinforcement bar lah. They arrange it in the hole, okay, follow the draw, okay, and then after that they pour concrete lah, or sometimes they, if that's necessary, then they will put a formwork, okay, and finally they concrete the structure lah. Okay, so that is how they construct, shallow foundation in the construction. Okay, okay, so the next slide is the on the ultimate soil bearing capacity for shallow foundation. Okay, okay, when the uniform distributed load Q per unit area is applied to the footing, it settle. Okay, meaning that if the uniform distributed load increase, the settlement will gradually increase lah. Okay, so when Q increase, okay, so the settlement also increase lah. Okay, okay, when the value of Q, okay, equal to Q, equal to QU, ultimate soil bearing capacity. Okay, so bearing capacity failure will occur. Okay, meaning that the footing will undergo a very large settlement without further increase of Q. Okay, meaning that if it achieve ultimate bearing capacity, okay, even though you not increase the load, it will also settle lah. Yeah. Okay, so this is the mode of failure. Okay, so we have three types of modes. Okay, first we have general shear failure. Okay, which usually occur in the dense or dense sands or stiff clay. Okay, second one is the local shear failure. Okay, they usually occur in the medium compaction sand or clay, or we have third one, we have punching shear failure. Usually occur in loose sand or soft clay lah. Okay, so this is the explanation on the general shear failure. Okay, so when you have a load, okay, so the QU is the ultimate bearing capacity of soil. Okay, so when the foundation settle under the application of the load, okay, it will have uh, a force, yeah, a force acting this one, number one, yeah, uh, number one, okay, push down, okay, the soil, okay, so the first shape will be number one lah, rectangular, okay, rectangular with shape zone, okay, and then it will press, okay, the surrounding soil which is number two and number two, okay, here number two, okay, and then it will push up the soil, okay, push up the soil, okay. So if the general shear failure occurred, you can see the bulging here, the bulging soil, yeah, beside the foundation. So you can define it as the general shear failure. So later on, when you go to the site, if you see the soil bulging, yeah, soil surrounding structure is bulging, meaning that the structure already undergo the general shear failure. Okay, and then second one is the local shear failure. Okay, meaning that, okay, the settlement is localized. Okay, so beyond a certain Q equal to QU, okay, so Q is the loads lah, applied load, okay, is equal to ultimate bearing capacity, QU, okay, QU prime is the ultimate bearing capacity here, okay. The load settlement relationship become a steep inclined straight line here, yeah, straight line, okay, so meaning that it's localized lah, okay. So if the local shear the structure undergo local shear failure, so you won't see the bulging here, yeah, because it localized under the structure, yeah, it not push the soil up, okay. So you can say it as a local shear failure lah, okay. And then we have punching shear failure, okay. Punching shear failure meaning that it really localized under the structure, okay. So usually this one the column lah, the column punching through, okay, the column punching through the um the slab, okay, okay, punching through the slab. So that's why when you design for your what we call it, when you design for your pile cap, so you have to check for the punching shear lah. We worried that if the it achieve beyond the ultimate bearing capacity, it will the punching shear will occur. So you have to check for the punching shear when you design for uh, uh, your pile cap. Okay, we don't want to the column punching through the slab, so you have to check, yeah, make sure it pass lah. Okay, so we will I will stop now. Okay, I will proceed with the next lecture on the design criteria. Okay, design consideration for the shallow foundation. Okay, bye. So discard. Okay. Thank you, student. Okay, I will stop and the session first. I will continue next section. Okay.